Alright, so the question I got was to help with, let me actually read the question. How do I get p-values? Okay. Sorry, I forgot the question. Alright, so we're given, according to census, 10.1% of all babies are a low birth weight. Okay, so let's talk about that number 10.1%. 10.1% is a percent or fraction or decimal, meaning the data we expect to get back is going to be some form of proportion. So we're looking at a proportional test, so a 1 prop z of some type. Let's see, we're told they randomly select 280 births. Okay, so we got a sample size of 280. If the proportion of low birth weights for the mother in this age group is 0.101, which is what we expect, compute the expected number of low births from the 280. So, and you actually got that right, so I'm sure this is exactly what you did, is take the number and multiply it by that percent. So I get 28.28. which is what one expects to see. So that the not a low birth weight then would be the sample, so the 280 minus that other number. And again, that's what you did. So we're on board. Okay, then we get this answer the obstetrician's question about a level of significance using a chi-square goodness of fit test. Ooh, okay, so now we got a slight change. We're looking at a goodness of fit or GOF test. So a goodness of fit test is it's where we have an expectation and a difference to see if it, so an observation and an expectation. Okay, let's see, so the null and alternative, so I expect the proportion to be that 0.101. And let me see if I can get where they're getting the greater than out of this. She randomly selects and found 30 low birth weights. Okay, so here's where they're getting the greater than. We expect only to see 28. In our sample of 280, we actually found 30. So we found more than the 28. And so the question is our observation of 30 so ridiculous that we think that there's an epidemic of some kind? Like, is 30 going to be enough that we start freaking out? Or is 30, I mean, if I expect 28 and I have 30, and no big deal, right? So that's what this p-value, that's what this number here is going to tell us, is if it's a big deal or not. I don't know why I'm doing that strange accent. Okay, so that's where they're getting the greater than piece, is because of the 30 compared to the 28. Okay, so in our calculator, we're going to go to test, and we're going to see if we can find a goodness of fit test, which is right there. It's that chi-square GOF test in my calculator. I guess it kind of depends. And okay, so here we go. It says observed. I observed 30. Oh, that didn't come out right. All right, let's see. What am I doing wrong here? I think I need to just tell it it's not an alpha. All right, so I observed 30. It's going to give me an error. It always seems to do that. All right, let me try that again. Chi-square, okay. Let me hit alpha. So 30. Oh, it's gonna, all right, let me keep working on this. Okay, so going back to the calculator. Sorry, it took me a while to figure out what I was doing wrong. And the problem is I went to the wrong screen. Okay, so let me show you this. We need to go to our list screen. And we need to input our observations and our expectations. So I observed 30 of the 280. Can I show you down here? 30 of the 280 that were considered low birth. So that meant 250 were not. And then I expected to see 28.28 of the low and 251.72 of the not low. Okay. All right, so then from here, I'm going to go to test, and I'm going to arrow up to goodness of fit, and the observed, those are my 30 and my 250, that goes in list 1, and then my expected was the 28.28, which went in list 2, and degrees of freedom. Okay, so in degrees of freedom, we have 2 categories. They are low birth or not low birth. And so since there's 2 categories, we're going to subtract 1. That'll give us degrees of freedom. And then I'll hit calculate, and haha, there's the magic number. Okay, so using a goodness of fit test, I would see an observation like this 73% of the time. And we only get excited if it's less than 5%. So clearly that's, 30 is not anything to get excited about at all. Okay, so that's why we're going to reject the null. Okay, so then what they do is they say, oddly enough, our data is also in the form of a proportion, so we can do a 1 prop z test on this. So here they're saying if our proportion, now notice you picked mu. Mu is a means test instead of a proportion test, so you do got to watch the variable there. So if our proportion is equal to 0.101, again, we've got a 30 here. So just kind of to type this in so we can see the percent that they're talking about here. If I do 30 divided by 280, so if I expect 0.101 and I scandalously see 0.107, is that something to get excited about? So that's where this 1 prop z analysis is going. So again, the reason why it's greater than is that I observed 0.107. So I observed a number bigger than what I expected. So again, my question is that so big that I need to get excited and alert the media and run for the hills, that sort of thing. Okay, so I'm going to go back to stat and go over to test, and I'm going to go to 1 prop z. Okay, and then I'm going to type in I expect to see 0.101. I observed 30 out of the 280, and it's greater than. And then I'll just calculate that. And I get, real quick clarification here, so that our p hat is my sample proportion, so that 0.107 we saw earlier. And I get that we would see this 0.36, so 37% of the time. I would see something as ridiculously high as 30. Now obviously if our get excited point is 5%, I'm sorry, they're actually telling us that alpha is 0.1, isn't it? Right there, level of significance is 10%. So they're saying if our sample is so rare that it would show up 10% or less, then that's evidence against something. We've got a sample that would show up 37% of the time. So clearly I am not calling the news media and running for the hills for this. This is very boring, average data. So since, I'm going to go back here to your choices, since our p-value, the 0.366, is greater than 0.1, I fail to reject the null. There is not enough or not sufficient evidence to conclude blah blah blah. Okay, that's why that bottom one is that choice. So hopefully this helped.